So this is a application problem in the world of physics, and many of you might want to go on and take physics. It's a really good class. So they give us a little background here, and I typed it all in just so that we would have it. But electrical parts such as resistors and capacitors come with specified values of their operating parameters, like resistance, capacitance, etc. However, due to imprecision in manufacturing, the actual values of these parameters vary somewhat from piece to piece. So manufacturers produce something, but they're not all going to be exactly what they're supposed to be. And so there's this window of what's acceptable. Okay, so the best that manufacturers can do is try to guarantee that the variations will stay within a specific range. Often 1%, plus or minus 1%, plus or minus 5%, or plus or minus 10%. Okay, so that's the idea here. So say it's supposed to, you're making something, it's supposed to be, I don't know, 10 ohms. So say you want it to be within plus or minus 1%. That means you're going to accept anything between 9 and 11 ohms. Okay, something like that. All right, so that's the idea here. So now they give us a problem. Oh, I don't know why that happened. Okay. Suppose we have a resistor rated at 680 ohms. 680 ohms, plus or minus 5%. Use the absolute value function to express the range of possible values for the actual resistance. So we're not going to actually write the range like in interval notation. We're going to use the absolute value function to express it. Okay, the first thing you have to do on this problem is figure out what's 5% of 680. So 680, and you want 5% of that, 5% of 680. So take on your calculator 680 times 0.05, and you get 34. Okay, so that's where the 34 comes from. So we're saying, okay, 680, it's got to be within 34 ohms of 680, plus or minus. The way we write it is we take our x, whatever it turns out to be, subtract the 680. So you're finding the difference between, oops, darn it. You're finding the difference between whatever your resistor, whatever its ohms are, you're going to subtract the 680, and then that number, whatever it is, has to be less than or equal to 34. Okay? So that's how we take this idea that there's this window within 5% accuracy of 680, and we write it as an absolute value function. Now you might say, well, why would you want to do that? Why not just put the range? It probably depends on the actual situation you're in. If you were plugging this into like a computer program, like you were programming something, you would want to base it on whatever value x is. Then you can put in all the values of x and determine which ones are less than or equal to 34. Okay? So just kind of an idea there. All right. So this is how we write it as an absolute value function.